Hi everybody, welcome to my talk. My name is Joris Vankerschaver from Ghent University Global Campus in South Korea, and I will be talking about enhancing data security in GA4GH implementations using Crypt4GH. So first of all, what does the GA4GH provide in terms of data and compute management? Well, they provide a number of building blocks that are motivated by large-scale processing of genomic data. One of the building blocks that we will be using on this poster is the Crypt4GH file format, which is a cryptographically secure open source file format that allows you to encrypt data, sensitive data at rest and in transit. Moreover, this file format allows for new users to easily be given access to encrypted data. The second building block that we will be considering is the so-called Task Execution Service, or TES, which defines a standard API for computational tasks and a way to execute these tasks on standard computing infrastructure such as Azure or AWS EC2. The last building block that we will be looking at is the Data Repository Service, which, like TES, provides a standard API to access, in this case, datasets. It is a standard that is interoperable with other GA4GH standards and is currently widely adopted by bioinformatics platforms such as Galaxy, and is also used worldwide with over 100 petabytes of data indexed at NIH, Elixir, and the Biobank Japan. Now that we have these building blocks, it makes sense to build a platform out of this. And this is the main topic of my poster and the topic that we are currently working on. In this platform, we have a centralized gateway that talks to an identity provider to check that the users are who they claim to be. If they pass that check, then the user is able to upload or download data, submit computational jobs, using the Data Repository Service and the Task Execution Service, where these two services then talk to standardized cloud infrastructure, such as S3 for storage and EC2 for external compute. And the platform then provides the user with reporting, with a way to manage jobs, and so on. In this way, we can build an open source, standardized platform that is modular, scalable, and federated, that can scale with the needs of the user, that can be deployed in multiple countries if there is a need to do so, and moreover, where data confidentiality can be guaranteed through the use of Crypt4GH and confidential computing. The latter is part of ongoing work, but the former, the use of Crypt4GH, is something that we have tried and where we have made available proof of concept code on an open source basis. How have we gone about adding Crypt4GH support to TES, to the Task Execution Service? Well, a TES task consists of multiple executors where every executor takes part of one computational aspect. To add Crypt4GH support, we simply insert a decryption executor before we run any of the other executors. This decryption executor will decrypt the files and store them in a temporary volume. It will also rewrite the inputs for the subsequent executors so that they refer to the decrypted files. And last, it will then hand off and run the other executors, possibly in a trusted execution environment. How do we add Crypt4GH support to DRS, to the Data Repository Service? Here we look at the incoming request from a user to retrieve their public key. We then re-encrypt the data that the user was requesting. This is a process that can be done very efficiently because only the header of the file needs to be re-encrypted, whereas the payload can stay as is. And then once we have that re-encrypted file, we modify the response from the DRS server to point to the re-encrypted data. In this way, the user receives a file that has been specially re-encrypted with their public-private key pair and is only accessible by them. The next steps in the development of our platform are to integrate these proof of concept implementations and to further build out a production-ready platform. Once that is ready, we are happy to provide public access and to support many use cases in open processing of genomic data. The code for the proofs of concept that I mentioned before is available online, but I'm also happy to provide a demo or to provide further information if needed. My contact details can be found on the poster, and I thank you for your time, and I hope to see you at the conference.